Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter pair of linear equations in two variables from 10th standard CBSE mathematics. So we will continue with exercise 3.5 and problem number 4, fifth sub problem in page number 63 of your textbook. So page number 63 and exercise 3.5, fourth problem, fifth sub problem. So important problem. The question is, I am reading the question. The area of a rectangle gets reduced by 9 square units if its length is reduced by 5 units and breadth is increased by 3 units. If we increase the length by 3 units and breadth by 2 units, the area increases by 67 square units. Find the dimensions of the rectangle. That is the question. Fine. So whenever we have such problem which talks about area increases or decreases depending on we increase or decrease the length or the breadth of the rectangle, area of the rectangle, right? In that case, we need to, and we have to find the dimensions of the rectangle. So which means length and breadth we have to find the dimensions for the rectangle. So we'll assume I'll start from here. We'll assume let the length of the rectangle is x units. We'll assume the length of the rectangle as x units, and we'll say let the breadth of the rectangle is y units. Whenever we have this area of the rectangle problem where the area is increasing or decreasing depending on length or breadth increasing or decreasing, then we need to write these statements like length you assume as x, breadth assume as y, then you say area of rectangle is what? Area of rectangle is given by length into breadth, L into B, right? Length into breadth, right? So what is the length of the rectangle? Right? Breadth. Length of the rectangle is x, breadth of the rectangle is y, right? So this is your area A. A is x into y. A is the area of the rectangle. Now let's read the question. What is given in the question, right? So these you can write without even reading the given information in the question, because the moment it talks about area of the rectangle, you can write these three, and then we will say it is given that its length is reduced by, if the length is reduced by 5 units and breadth is increased by 3 units, which means if the length is what? X, right? So if the length is x, I'm reading the first line, right? The area of the rectangle gets reduced by 9 square units if the length is reduced by 5, which means x is reduced by 5 means x minus 5, and the breadth is increased by 3 units, which means this is the length into breadth. Breadth is how much? Breadth is increased by 3 units. So y is the breadth. Y plus 3. So this is a new length and new breadth. If the length of the rectangle reduces by 5 means x minus 5, and the breadth is increased by 3 means so y plus 3. Then the area becomes what? The area of the rectangle gets reduced by 9 square units, which means area is area minus 9. Initially, what was the area? A. Now it is reduced. So initially the length was x and breadth was y. A was the area. Now when length reduces means x minus 5, breadth increases means y plus 3, and length into breadth is what? The new area. New area of this length and this breadth. And new area is what? 9 less than the original area. The area gets reduced by 9 means a minus 9. Right? Now we will simplify. So this is the equation that we got from the first information or the first statement or first part of the question. We will read the second sentence in the question and we will form the second equation. So always they will give you two information to form two equations. Right? So from the first information we got this equation. Now let's multiply this. So what do we get? So x into y is xy. Then x into 3 is 3x. And minus 5 into y is minus 5y. Minus 5 into plus 3 is minus 15. So we are multiplying normal multiplication. X into y is xy, x into 3 is 3x, minus 5 into y is minus 5y, minus 5 into plus 3 is equal to area minus 9, a minus 9, right? Now what is xy? X into y is what? X into y is what? Area. So instead of this xy, I can put area a, or I can convert this one also as xy, doesn't matter. I will not bring in the new variable. Xy plus 3x minus 5y minus 15 equal to what is area? What is the value of a? A is what? X into y, which means xy. So area is xy minus 9, right? Now we'll bring all the variables to one side, numbers to the other side. So xy plus 3x minus 5y. I'm bringing this xy here, it will become minus xy equal to minus 9 is here, and minus 15 goes this side, it will become plus 15. So xy, this is minus xy, they get cancelled. You get 3x minus 5y equal to 6, 15 minus 9. So this is your first equation. This is one equation that we have got. Now we need to read the second statement or second information given in the question to form the second equation. So what is the second one? Second statement say if we increase the length by 3 units, then x plus 3, the length is increased by 3, length is x, and the breadth by 2. We are increasing the length by 3 and breadth by 2. So breadth is also increasing. So length into breadth is also increasing by 2. So length is increasing by 3, breadth is increasing by 2. Length is increasing by 3 means x plus 3. Breadth is increasing by 2 means y plus 2. And the area, what happens? The area increases by 67 square units. So area also increases by 67, which means area plus 67. A is the original area. X is the original length, y is the original breadth, and A is the original area. Original length is x, original breadth is y, original area is A. If I increase the length by 3 and increase the breadth by 2, then the area is increased by 67. That is the meaning of this. Length and breadth is what? Area. So now what is, now again multiply this, what is x into y? Xy, x into 2, 2x, 3 into y, 3y, 3 into 2, 6 equal to A. A is what? X into y. A is the original area. Plus 67. Now bring all the variables to one side and numbers to other side. So xy plus 2x plus 3x minus xy. This xy comes here. It will become minus xy. Because here it is plus xy. If it comes here, it will be minus xy. Same as this. Now again 67. This 6 goes this side. It will become minus 6. So the equation becomes now here, this is plus xy minus xy. They get cancelled. You get 2x plus 3y equal to 61. So this is your second equation. Now we have got two equations. Right? I am writing the equations here. They are 3x minus 5y equal to 6. This is one equation. Right? And the other equation is the first equation. The other equation is 2x plus 3y equal to 61. The second equation. Now we need to check whether the solution exists or not. Right? That is the question. If you read the line in the fourth question, form the pair of linear equations in the following problems and find their solutions if they exist by any algebraic method. So we'll check whether the solution exists or not. To check whether the solution exists or not, we need to compare the ratios in the table 3.4 in page number 46 of your textbook, NCERT book. So we need to check that. So to check the ratio which is there in the table 3.4 of your textbook, page number 46, we need to write the given equations in the standard form. What is the standard form? Standard form of linear equation is like this: ax1 plus by1 plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. This is the general form of linear equations in two variables, pair of linear equations in two variables. Now I need to convert this in that form, means the right side we should have 0. So which means we should bring everything to the left side. So this becomes 3x minus 5y. This 6 will come here to become minus 6 equal to 0. This is the equation 1 becomes like this. Equation 2 becomes 2x plus 3y minus 61 equal to 0, which is your second equation. Now both the equations have been rewritten in this form, which is matching with the general form of pair of linear equations in two variables. Now let's compare what is a1x b1y, not ax1. a1x plus b1y plus c1 equal to 0. It takes Right? Now compare these two. Then what is your A1? A1 is, compare this. A1 is the coefficient of x in the first equation. This is your first equation. This is your second equation. Clear? Now A1 is what? A1 is the coefficient of x in the first equation, which is 3, comma B1 is 5. No, it is minus 5. So you have to take along with the sign. Right? What is C1? C1 is this. What is this? Minus 6. Now A2 is coefficient of x in the second equation, which is 2. B2 is 3. C2 is the constant term, which is minus 61. This is A2, this is B2, this is C2, along with the sign. Here A1, B1, C1. If you compare this with this. Now let's check the ratio. What is A1 by A2? 3 by 2. Then we should find B1 by B2, because we are trying to check the ratio that is given in the page number 46, table 3.4 in your textbook. Now A1 by A2 is 3 by 2, B1 by B2 is minus 5 by 3. So which means what do you see? You see that A1 by A2 is not equal to B1 by B2. Right? They are not equal, because this is 3 by 2, this is minus 5 by 3. Therefore, as per the table, right, the ratio that you see, there are 3 conditions that you need to know actually. Right? For the time being you can refer, but you need to know that ratio. A1 by A2 not equal to B1 by B2 means what the table says. Table 3.4 in page number 46. For this condition, it has unique solution. Unique solution. Right? Which means it has only one solution. Unique means only one. Only one solution. Now we should solve them. We should solve and find the solution, which means we should find the value of x and y, because we need to find the length and the breadth of the rectangle. Now to solve this, we'll solve by elimination method. Okay, we can use any method. So we'll solve by elimination method. Elimination method. So let's write the equation. We have to go back to this form. For elimination method, the equation should be in this form. For cross multiplication method, the equation should be in this form, or whenever you are finding this ratio, whenever you want A1, B1, C1, then the equation should be in this form, which is this form. Right side should be equal to 0. For elimination method, you can take this equation, the 3x. I'll do one thing. I will write here. Let me erase this. So let me rewrite. So it is 3x minus 5y equal to 6. This is first equation. Then 2x plus 3y equal to 61. This is your second equation. Now what we should do for elimination method? We should check whether anything has coefficient 1. Okay, sorry, whether the coefficient of x or coefficient of y is same in both the equation. That is the first check that we will check for elimination method. So we are going to solve this by elimination method. Elimination method. We can choose any method, elimination or substitution or cross multiplication, but easiest method is elimination method. Now for elimination method, we should check whether the coefficient of x or coefficient of y are same. One of them should be same. What is the coefficient of x here? 3. Here it is 2. They are not same. Again here coefficient of y is 5. It's basically minus 5. Here it is 3. So they are not same. We can have minus 5 and plus 5. That is okay. The coefficient can have a different sign, but the numerical value should be same, but that is not same here or here. So now, which means we need to make them same. How do we make them same? Let's take this 2 and multiply this equation throughout by this 2, and multiply the second equation throughout by this 3. So if I multiply this 3x with 2, it will become 6x. If I multiply 3 with 2x, it will become 6x. So we are going to multiply the first equation by 2 and the second equation by this 3. So we will say multiply 1 means equation 1 by what? By the coefficient of x, the second one 2, and equation 2 by this equation by 3. This is equation 2 by 3. So what do we get? We get, if I multiply the first equation by 2, this means this equation, everything should be multiplied by 2. Not only this. So 3x into 2 is 6x, minus 5y into 2 is 10y, then 6 into 2 is 12. So I multiplied this throughout by 2 and I got this. We can call this, if you want, we can call this as same equation, or we can put equation 3, doesn't matter. right? Then this equation here we will multiply the second equation by 3. So 3 into 2x is 6x, then 3 into 3y is 9y, 3 into 61 is 183. This is our fourth equation. Right? The first equation has become like this. Now second equation has become like this. Now let's solve this. Now you see the coefficient of x is same, 6. Now you need to check the sign. This is plus 6, this is plus 6. When both are same sign, then we must subtract them. We have to subtract this minus this. When we have to subtract, then the signs will change. So plus will become minus. Here it is plus, it will become minus. Here also it is plus, it will become minus. Now cancel these two. This is plus 6x, this is minus 6x. Now this is minus 10y, this is not plus 9y, it is minus 9y. You have to see the change sign. So plus 10y minus 9y is minus 19y equal to 183 minus 12 is what? Minus 171. Right? If you subtract, right? 12 minus 183 is minus 171. So y will become minus 171 by minus 19. So that will give you, if you cancel, minus minus will get cancelled, right? Minus minus will get cancelled. You will get plus 19 nines are 171. So we got the value of y. Now we should find the value of x. Now how do we find the value of x? We should substitute y is equal to 9. So what we got is, we got y is equal to 9. Substitute y is equal to 9 in any one of the equation. Right? Any one we can substitute. So we'll substitute y is equal to 9 in first equation, in 1. What is the first equation? 3x minus 5y equal to 6. So 3x minus 5. In the place of y I should put 9. So 5y means 5 into y, which means 5 into 9 equal to 6. So which means 3x plus 45, sorry, minus 45 equal to 6. So 3x is equal to 6 plus 45. So which means 3x is equal to 51. X is equal to 51 by 3, which is 17. So what we have got? We have got x is 17, y is 9, which means the answer is, length is equal to length of the rectangle. That is the answer. Length of the rectangle equal to 17 units, and the breadth of the rectangle equal to 9 units. Right? Length is 17, length of the breadth of the rectangle is 9 units. So this is the answer. You can substitute these two values in this equation and you can check whether you get 6, and you can substitute in this equation and you can see whether it is 61. It will match in case if you want to do the verification of this. Clear? Understood how to do this problem? Fine. Now let's go to next section, which is called as, I'll erase this. So next section is the same page number 63. It is equation reducible to a pair of linear equations in two variables. Equations reducible to pair of linear equations in two variables. Right? Equations reducible to a pair of linear equations in two variables. See, suppose we may get into a situation where the given set of equations may not be linear equations in two variables. But we can make some substitution and make them as a linear equations in two variables. That's why it's called as equation reducible to. Reducible to means we can make it as a linear equations in two variables. Certain equations which are not linear equations in two variables, we can make it as a linear equations by making some proper substitution. That's what we'll see in this section. Let's see example 17. In example 17, the same page number 63. Example 17. Fine. So what it is? It says solve the pair of equations 2 by x plus 3 by y 2 by x plus 3 by y. We have to solve this by equal to 13, first equation, and 5 by x minus 4 by y. 5 by x minus 4 by y. 5 by x minus 4 by y equal to minus 2. This is your second equation. Now, if you observe these two equations, they are not linear equations in two variables because they are not in this form. You should have a1x, but x is in the denominator. The moment you see the variables x or y in the denominator, whenever you see the variables in the denominator, a variable should be always in the numerator like this, 3x. You cannot have 3 by x. If you have 3 by x or 5 by y, which is in this form. This is not linear equations in two variables. It's not a linear equation at all. It has two variables, but it is not a linear equation. Right? So now, which means we can convert this into linear equations we can convert this in this form by making some substitution. What substitution we can make? Suppose if you observe this, right? So if you observe this, this can be written as 2 into 1 by x. 2 by x means 2 into 1 by x plus 3 by y means 3 into 1 by y. 3 into 1 by y is 3 by y equal to 13. And this is 5 into 1 by x minus 4 into 1 by y equal to minus 2. Right? 5 by x means 5 into 1 by x. 4 by y means 4 into 1 by y. Now what we can try to do is we can put some substitution. We can put 1 by x. We can put this 1 by x. We'll say we are going to make some substitution. So we'll put 1 by x as some number. We'll put 1 by x as some variable. Sorry, not number, p. We'll put 1 by x as small p, right? And my 1 by y as small q, right? If we substitute, we can say substitute. We are going to substitute 1 by x as p, 1 by y as q in the above equation. Then what this will become? So 2, 1 by x will become p. So 2p plus 3, 1 by y is q. So 3q equal to 13. Then again go here. 5 into 1 by x. 1 by x is p. So 5p minus this is 4 into 1 by y. 1 by y is q. Q equal to minus 2. Right? So wherever 1 by x is there, we have put p. Wherever 1 by y is there, we have put q. Then this equation becomes like this. Now I call this as 3 and 4. Now what you observe? Now this has become like a linear equations in two variables. The variables are p and q. See, ultimately we have to find the value of x and y. Ultimately we have to find the value of x and y. But since this equation is not in the pair of linear equations in two variables form, so we are converting them into a pair of linear equations in two variables using a substitution of 1 by x with another variable 1 by y as y with 1 by y as q with in this equation. So we are substituting 1 by x as p, 1 by y as q in this equation to convert the given set of equations as a linear equations in two variables. Here the variables in this are p and q. So we will find p and q. After finding p and q, we will substitute here to find x and y. So first we will find p and q. So now this is our normal linear equations in two variables. We can solve this by any method. We can solve this by any method. We will solve this by again substitution method, elimination method. Always we go for elimination method. So you can do any method unless they ask you to do in a particular method. Then you need to do that method. Right. So this is equation 3. I'm just rewriting that. Then 5p minus 4q equal to minus 2. That is your fourth equation. Now for elimination method, what do we do? Again we are going to solve by elimination method. Elimination method, we have to check whether the variable, whether the coefficient of the variable x is, here not x, it is p. Whether the coefficient of the variable p is same in both the equation or coefficient of q in both the equations are same. What is the coefficient of p here? In this it is 2, here it is 5. They are not same. Let's check the coefficient of q, at least whether the coefficient of q is same. Here it is 3, here it is minus 4. So they are not same. then we should make them same by multiplying the equation 1 with some number and equation 2 with some other number. What those numbers are, now let's observe here. If we can multiply this equation throughout by 5, if you multiply 2p everything, this entire equation 3 by 5, then this will become 10p. These also will become, this will become 15q, this will become 65, but this will become 10p. Again, if you multiply the equation 4 with this 2, the coefficient of p here with this equation 2 with 2, if I multiply this, this will also become 10. So I'll multiply this with 5. So the 2 into 5, this will become 10. If I multiply this with this 2, this will also become 10. So both will have the same coefficient. So we'll say multiplying equation 3 by what? This entire equation 3 by 5. Number 5. And equation 4 by what? Equation this 4 by this 2. We get what we get. Fine. So what we'll be getting is, now substitute. We'll get 3 should be multiplied by 5. So equation 3. So which means 5 into 2p, 10p. Everything here we have to multiply by 5. So 10p, then 3q into 5 is 15q, equal to 13 into 5 is 65. Similarly, multiply the equation 4 by 2. So 5p into 2 is 10p. Then again minus 4q into 2 will give me 8q. Then minus 2 into 2 gives me minus 4. Right? 5 2s are 10, 4 2s are 8, minus 2 into 2 is minus 4. Now we have to see whether we need to add or subtract. So I can call this as, if you want, 5th equation and 6th equation. Now we have to add or subtract. Fine. Now to add or subtract, we need to check what is the sign of this. 10, both are 10. Now we have made the coefficient same. Now check whether the signs are also same. This is plus, this is plus. When both have the same sign, then we should subtract them, which means we should change the sign of the second equation. So we will put minus because it is plus. So here it is minus, it will become plus. This minus will become plus. Now this is 10p, this is minus 10p, cancel. 15q plus 8q is 23q, equal to, now 65 plus 4 is 69. You have to always see the change in the sign. Don't think that 64 minus 4 and don't put 61. This minus 4 has become plus 4. Because we have changed all the sign. Why we are changing all the sign? Because without this, this was also 10p, this was also 10p. When the signs are same, then you need to subtract the equation, which means we should change the sign. So now we get q is equal to 69 by 23, which gives me 3. What is my q? My q is 3, because 23 3s are 69. Now we got the value of q. Substitute in one of the equation and find the value of p. So we'll substitute q equal to 3 in third equation. We get what we get. So third equation is what? 2p plus 3q equal to 13. Right? So if I substitute q is equal to 3 in this, I'll get 2p plus 3 into 3 equal to 13. 2p plus 9 equal to 13. 2p is equal to 13 minus 9. So 2p equal to 4. So p is equal to 4 by 2. So p is 2. So what we have got? We got the value of p as 2 and q is 3. Right? So now we have got the value of p and q. Now we need to, finally we are supposed to find the value of, we have to find the value of x and y. Now let's take here this one. 1 by x is what? 1 by x is p. And what is the value of p? P is 2. Substitute p as 2. So you will get 1 by x is equal to 2. When 1 by x is equal to 2, so this, right? So then this x will go here. If x goes here, it will become 1 is equal to 2x. Right? When 1 is equal to 2x, I can write 2x is equal to 1. Now what is my x here? 1 by 2. So we have found x. Right? Similarly, we'll put what is 1 by y. 1 by y is q from here. And what is the value of q? Is 3. So put 1 by y is equal to q. Q is 3. So you get 1 by 1 equal to, this y will go this side. It will go to the numerator 3y. Which means I can write 3y equal to 1. I can write whole thing here. 1 equal to 3y means I can write as 3y equal to 1. Then y becomes 1 by 3. So what is our answer? So our answer is x is equal to 1 by 2, comma, y is equal to 1 by 3. So that is our answer. Clear? Now if you substitute x is equal to 1 by 2 and y is equal to 1 by 3 here, you will get 13 and minus 2. Fine. That you can check as a verification if you want, but that is not a required step. This here the problem ends. Clear? So x is 1 by 2, y is 1 by 3. Clear? So I will stop here. We will continue the next examples in the next video. You please continue to watch my next video for the continuation of this chapter. Thank you.